Tomorrow we're going to extract the diol that we made from the epoxide opening. So this video is going to talk about that. This is the first reaction that we did. We stirred the epoxide with acetic acid, and then we added water, stirred for 30 minutes. But no one's reaction was working, so we had to kind of backtrack and figure out what was going on. So what I did after you guys left last week was I added a little bit more sulfuric acid to each reaction, and then I heated the reaction, and I noticed that the reaction, once it got to 70 degrees, all the solid got dissolved. If it was below 70, then there was still white solid in the reaction mixture. But once I got it to 70 degrees, I noticed that everything went into solution. So what actually happened, if you look at the TLC plate here, you can see that this reaction, this one, many of these reactions went to completion. A few of them still had epoxide left over. That's what these spots are up top. If you remember, the RF value for the epoxide was pretty high relative to the diol. And so what we want to do now is go ahead and try and isolate the diol, and we're going to have to do that using what we call a liquid-liquid extraction. So you take two liquids that are not soluble in one another, you shake them together in a separatory funnel. Once those two liquids are shaken together, you'll get two layers, and then one of your solvents is used to remove the desired compound from the other layer. So I'll talk about that, more about that in a minute. So your solvents have to be different, at least based on the density and possibly the polarity, because a lot of times you'll have compounds that are polar that are stuck in one layer, and you want to remove them from that layer. So you need a more polar solvent to do that. The layer that you want to that you think contains your compound, you want to keep, and the other layer you discard, but you don't throw anything away till you make sure that you have everything isolated. Alright, so let's look at just kind of a schematic. First thing we're going to have to do is neutralize the reaction mixture with sodium hydroxide, and that's because we added sulfuric acid. So we need to neutralize that. So we're going to add sodium hydroxide to the reaction mixture until it's neutral. How do we know when it's neutral? We can check the pH using the pH color chart. When the pH is at 7, we know it's neutral. And then after we neutralize it, then we'll do the extraction part. So this is a separatory funnel. Notice I have a little conical funnel here. So I'll add my aqueous layer right to the separatory funnel, and then I'll come back and add my solvent that I want to do the extraction with to the aqueous layer. In this case, we're going to use ethyl acetate, and so I'll add that to the separatory funnel, and now I should have two layers where one layer, the top layer, is going to be the less dense solvent, and the bottom layer will be the more dense solvent. Depending on what solvents you use, that's going to determine which layers on the top, which layers on the bottom. Alright, so what's next after this? Well, you do what's called a shake and vent, and I'll show you. I think it's better to demonstrate this using a video clip. So watch this short clip, and then we'll come back and finish this up.
Now there's two. Now ethyl acetate and water are not miscible, meaning they don't dissolve in one another. So the technique of extraction is using a separatory funnel. Is we have the two solvents, and you should see roughly two layers. But if we were to just let it sit here, there's not much contact between the two layers, so we have to mix them. Now there's two different ways you can mix material using a separatory funnel. You want to grab it with, generally you want to grab a separatory funnel with two hands. I have bigger hands. This is a smaller separatory funnel. So you want to invert it and release any pressure that may have arisen. And then you can gently swirl the solution. You can swirl this for 15 or 20 seconds and release the pressure. That's one way of doing it, and the gentle mixing is very important when there's a possibility of forming an emulsion. Okay, and an emulsion I'll describe a little later, and I'll actually show you what an emulsion looks like. Or you can really shake it a couple times and release the pressure. Okay, You want to do that 3 or 4 times. And what this is doing is basically allowing the two solutions to come into contact with one another. The more surface area, the more contact, and the better transfer of caffeine to the organic layer. Okay? While this is separating, it may take a little while, but while these two layers are separating, you should label.
Alright, so here's the procedure for the workup. We're going to again neutralize with sodium hydroxide, add the aqueous layer to a separatory funnel, add 25 mils of ethyl acetate, shake and vent just like you saw in the previous clip to mix the layers. Let the layers separate, and then you're going to take off the aqueous layer into an Erlenmeyer flask and then drain off the organic layer into an Erlenmeyer flask. After you do this part, you're going to put the aqueous layer back into a separatory funnel and then add 25 more milliliters of ethyl acetate and then do the extraction. Again, we're going to do the extraction 3 times, and then we're going to combine the organic layers, dry them with mag sulfate, and then filter, and then we'll concentrate the organic layer by letting the solvent evaporate. So normally we would do this with a rotary evaporator, but I think for our lab for tomorrow, we'll just let it evaporate in the hood. Alright, so if you have any questions, just shoot me an email, and I'll see you for lab tomorrow. Thanks.